We're going to talk a little bit about radicals. We have the quantity 2x to the 12th over y to the 9th raised to the 1/3. Now in radical form, and I couldn't type the radical form, but this would be the cube root of 2x to the 12th over y to the 9th, knowing that the 1/3 power is the cube root. So multiplying 2x to the, or raising 2x to the 12th over y to the 9th to the 1/3 power, same as taking the cube root, means that we're going to raise 2 to the 1/3. We're going to raise x to the 12th to the 1/3. We're going to raise y to the 9th in the denominator here to the 1/3. So we get 2 to the 1/3 multiplied by, well, x to the 12th to the 1/3, a power of a power. You're going to multiply the powers. So 12 times 1/3. And similarly down here, y to the 9th to the 1/3 is y to the 9 times 1/3. And 12 times 1/3 is 4, so we have x to the 4th. 9 times 1/3 is 3, so we have y to the 3rd here. And now we can write this as 2 to the 1/3 could be written as cube root of 2, and then that's times x to the 4th over y to the 3rd. So that's a fairly straightforward simplification. Now let's take square root of 32x cubed times the square root of 2x. I can multiply what's inside. Well, the square root of one thing times the square root of another thing is the square root of the product of those two things. So the square root of this times the square root of this is the square root of this times this. This times this, 2 times 32 gives us 64, x times x cubed gives us x to the 4th. Now, it's not actually necessary in this case because we know what the square root of 64 is, but I'm going to use a more general procedure, and I'm going to write 64 as a product of prime numbers. And it's very clear that if we break 64 down and continue breaking it down until we get numbers we can't break anymore, all those numbers are going to be 2, and there are going to be 6 of them. So for example, 16 times 4. Well, 16 could break down into 4 times 4, so we'd have 4 times 4 times 4. Each 4 could break down into 2 times 2. So we're going to have 2 times 2, 2 times 2, 2 times 2. That's 6. Okay, so we have 2 to the 6th. Anyhow, we have the square root of 2 to the 6th, x to the 4th, and we separate that out as the square root of 2 to the 6th and the square root of x to the 4th. Now, just to be careful about our exponents, the 2 to the 6th square roots, I'm going to write the square roots as 1/2 powers. So we have 2 to the 6th to the 1/2, x to the 4th to the 1/2. So we're going to have 6 times 1/2 for the power here, 4 times 1/2 for the power here. So the powers are going to be 3 and 2. And we're going to then have 2 to the 3rd, which is 8, and x squared. Now we look at the square root of 125x to the 5th over y squared. 125 factors down into 5 cubed, and then we have our x to the 5th over y squared. That's going to be equal to the square root of 5 cubed times the square root of x to the 5th divided by the square root of y squared. Now the square root of y squared is the absolute value of y. It's not y, it's the absolute value of y. Okay, because y could be negative. If we squared negative 3, we would get 9. The square root of 9 is 3, not negative 3. And it's not plus or minus 3 either. The square root of 9 is 3. So if y equals negative 3, the square root of y squared, being 3, is equal not to y, but to the absolute value of y. Okay, well, 5 cubed can be written as 5 squared times 5. The advantage being we can simplify the square root of 5 squared. Square root of 5 is going to remain square root of 5. The square root of x to the 5th is what? Well, we can factor that into x to the 4th times x. And the square root of x to the 4th is going to be easy to do. And of course, we're going to be left with the square root of x we can't do anything with. So what we have, the square root of 5 squared is 5. The square root of x to the 4th is x squared. We don't need any absolute value because x squared is always positive or 0. Can't be negative. So we see that this simplifies down to this, and we can write this as in slightly better form than I have here, as 5 times the square root of 5. Actually, we can't really improve the form. X squared times the square root of x. I'm not sure what I thought I was saying. So, didn't really add anything, so you've got to ignore that. Okay. So, we're going to look at a little rationalization and a little bit with complex numbers in a minute.